In this section, we want to start our work with square roots. I've written a definition over here on the board for the square root. If x is a positive number, then this stands for the square root of x, and it is the positive number we square in order to get x. So, for instance, the square root of 9 is 3 because 3 squared is 9. Likewise, the square root of 121 is 11 because 11 squared is 121. Now we have cube roots over here, which are numbers that we cube to get what's inside there. But first, let's go to the board and look at some square root problems. It says simplify, and the first one I have is the square root of 81. Well, that's the number that I square to get 81. That's what this stands for, the positive number I square to get 81. That's 9 because 9 squared is 81. So the square root of 81, or the positive square root of 81, is 9 because 9 to the second power gives us 81. So square roots really are the reverse of exponents. Let's look at our next one. Let's simplify 16 times the square root of 9. Well, this will be 16 times. This stands for the number that I square to get 9. That number is 3. And then 16 times 3, going to be 48. So this is multiplication. 16 times square root 9 stands for multiplication. These aren't connected together. It's simply multiplication when I don't see the operation symbol shown there. Positive square root of 9 is 3. 16 times 3, 48. Here's our next one. Square root 49 plus square root 64. Let's simplify. Square root of 49, this is the positive number I square to get 49. That's 7. Plus square root 64, this is the positive number I square to get 64. That's 8. 7 plus 8, 15. So that simplifies very nicely down to just 15. So positive square root 49 plus positive square root 64 is 7 plus 8, and that comes out to be 15. Let's try another problem similar to that. Square root 16 minus square root 9. This is the positive number I square to get 16. That's 4. Minus, that's that subtraction sign, the positive number I square to get 9, which is 3. 4 subtract 3 will be the number 1. So a nice simple problem here, just using the definition for these square roots. Okay, let's go on to problem number 5. Here it's a little bit more complicated. 3 times the square root of 25 minus 9 times the square root of 49. So this will be 3 times square root 25 is 5 minus 9 times positive square root of 49 is 7. 3 times 5 is 15 minus 9 times 7 is 63, which is 48. Okay, so I simplify each of these roots right here, then I do my multiplication, and then finally I do my subtraction to end up with 48. Our next problem is a square root that involves a fraction. Let's find the number we square to get 16/49. Well, this will be the number that we square to get 16 in the numerator and 49 in the denominator. How about 4/7? 4/7 times 4/7 will be 16 over 49. So 4/7 is the answer to that. Square root 16 over 49 is 4/7. Our next problem, square root of 100 over 121. Let's see. The number I would square to get this fraction will be 10 over, let's see, the number I squared to get 121 is 11, so 10 over 11. So I can take square roots of fractions just like I can take square roots of whole numbers. I simply look for the number that I square to get what's under that square root sign. Let's look at a couple of problems now where we approximate some square roots. Problem number 8, I have 5 times the square root of 5, and I want to approximate this with a decimal. So I'm going to use a calculator to look up square root of 5. So 5 square root, I get 2.236. Now that's just to the nearest thousandth. Now I want to take that and multiply by 5. And that comes out to be 11.180. So 11.180. So if I have a calculator, I can simply press that 5 and enter 5 and then press the square root button, and I'll end up with a decimal approximation to that square root. Once I have that, I can use the calculator to multiply that by 5 and get this. Let's try a decimal approximation to this right here. Square root 18, I'll do that on the calculator, and let's just go to the nearest thousandth again. This is 4.243 plus, now square root 19, and that comes out 4.359. So 4.243, 4.359, and then let's add those up. 4.243 plus 4.359, and that gives me 8.602. Now that's the decimal approximation to the sum of these two things right here. Now a real common mistake that I see students make all the time when they work with square roots is this. They'll take square root 18 plus square root 9 and they'll write it as square root, or they'll think of it as square root of 18 plus 9. There is no property of square roots that allows us to add square roots this way, and one way to see that this won't work is to take 18 plus 19 and then find its square root. You'll see that you don't get 8.602. Let's try it. So I'll take 18 plus 19, that's 37. When I take the square root, I get 6.08. 6.08 for the square root of the sum 18 plus 19. So you can see that's not the same as the sum of the square root of 18 plus the square root of 19. Now one last thing to do in this section, I want to go over to the other board here and take a look at what's called the Pythagorean Theorem. The Pythagorean Theorem has to do with right triangles, and what it says is that the square of the longest side is always equal to the sum of the squares of the other two sides. Another way to say the same thing is that this longest side, which is called the hypotenuse, is always equal to the square root of the sum of the squares of these other two sides right here. So what we want to do is go to the board and work a problem that involves one of these right triangles. So I've written down here, find x, and I have a right triangle in which the hypotenuse I've labeled with x, one side is 5 and the other side is 12. Well, by the Pythagorean theorem, I know that x is equal to the square root of 5 squared plus 12 squared. So I have the square root of 5 squared plus 12 squared. That will be the square root of 5 squared is 25, plus 12 squared is 144. So I have 25 plus 144. If I add those up, see, I get the square root of 169, and the square root of 169 we know to be 13. So if one side is 5, the other side is 12 in a right triangle, then the hypotenuse must be equal to 13 according to the Pythagorean theorem. So the Pythagorean theorem is a theorem that's been around for 2,000 years that involves a square root.